of this was the last thing that I gave. Hope everyone gave it a try. How do we proceed with this? Anyone got an answer for this? Now listen. So first thing, when you see this function, if you have noticed, we know r bar is xi cap plus yj cap. And if you look at the magnitude of this mod r is root over x square plus y square. That means if you look at the function there force, you can write that thing as minus r bar by r cube, isn't it? And this can be also written as r bar is nothing but r magnitude into r cap unit vector by r cube. If you see, we get force F bar is equal to minus r cap by r square. These kind of forces are called central forces. What are central forces? So these forces always act towards a point. These forces are always directed towards a point. Now, in this case, normally what is r bar? If you take a point here, x comma y, this is r bar, isn't it? Then what is minus r bar? Minus r bar is inside, isn't it? Force. That means no matter which point you take, the force will be always towards the origin here. So these kind of forces are called central forces. So this force F is always towards the origin. You take any coordinate, the force will always look at the origin. And you have seen a force like this before also, you know where? Remember this question? F3 is always looking at B. This is also a central force. The force F3 is always directed towards B. This is also a central force. So have a look at this page. So how do we handle these things? So let me give you more examples of a central force. Again, central force is not a new force. Any force that is directed towards a point is called a central force. If I give you one more example, let's say we have the sun and we have some comet which is going in an elliptical orbit. Now, if you look at the force between the sun and the comet, the force is always towards the sun. When the comet is here, the force is towards the sun. So here, if you see, the gravitational force is a central force. So don't think central force is some new kind of force. So any force like tension can be central force. If I give you one more example, if you take hydrogen atom and if you take an electron going in a circle, you can say all centripetal forces are central forces. But even in an ellipse, you can get a central force. So here, electrostatic force is central force. Mathematically, if you have F is equal to minus K R bar, it's a central force. F is equal to, you have something like K R square R cap, it's a central force. So R cap means radial direction. So any force that is in a radial direction is the central force. I can take even more weird functions like minus r by root over r square plus 1 r cap. All these are central forces if they depend on r. What if this guy, if you take y is equal to y I cap minus xj cap? What do you think about this guy? Is this a central force? So basically, if you can write something in the form of r bar xi plus yj, it's called a central force. Look at this guy. R bar is xi plus yj. If you notice something, both are perpendicular. F bar is perpendicular to R bar. Do the dot product zero aega. This is actually a, if this is your R bar, this is your F bar. This is a tangential force. Y I cap minus xj cap. This is not a central force. So the simple way to remember is if you can write this in the form of xi plus yj, which is R bar, it's always a central force. Any other form is not a central force. Please have a look at the examples. Have a look at this page. We still didn't do the question. We need to find the work done. But the thing is, this category of forces are called central forces. All clear with this page? Have a look at these examples also. Clear? Any doubts on this? So how do you calculate the work done? So we got the forces minus r cap by r square. Remember, dr bar is nothing but dr magnitude into r cap. So when you take the work done, this is integral f bar dot dr bar. This would be minus r cap by r square dot dr bar. And dr bar is parallel to r cap. So that becomes simply integral dr by r square. Because the dot product will be mod r cap, mod dr, angle between them is 0. What is r cap? It's a unit vector, isn't it? Unit vector ka magnitude is 1. So this integral will go limits from Ra to Rb. What is 1 by r square ka integral? Minus 1 by r. R power, x power n ka formula everyone. R power minus 2 plus 1 by minus 2 plus 1. Limits will go from Ra to Rb. What is Ra and Rb here? This is 1 comma 1. This is 2 comma 3. This is your Ra and this is your Rb. So Ra will be root 2, Rb will be root over 2 square plus 4 square root 13. So this will be 1 by root 13 by 1 by root 2. That's your answer. And if you notice something here, you will notice the work done is independent of the path. Means I don't need to know how you are going from A to B. It only depends on the initial and the final position. The work done by central forces are independent of the path. It only depends on the initial and the final position. In chemistry, right, these kind of functions are called state functions. Did you guys study anything like that? In chemistry, you call them state functions. They depend only on in case of chemistry, no, it depends only on temperature. Remember, it doesn't depend how you go from A to B. It depends only on the initial and the final temperature. So in chemistry, we call it state functions. In physics, we call this thing, it's a path independent functions. Have a look at this. So that is the thing. So the main idea is you can write this in the form of an R bar. If you actually see now, these are polar coordinates. We have discussed this in basic maths. If you remember polar coordinates, meaning in polar coordinates, the world will be right like circular. We have radial direction and tangential direction. So in case you have no idea about it, you should go back to basic maths. We had a discussion on that. Polar coordinates. Should definitely go and revise this once. It is a way of describing, just like x-axis and y-axis, you can describe something like r bars and tangential directions and radial directions. Just an idea there. Have a look at this. Any doubts on this? Next one. Farhan, can I go ahead? Pranjali? Vishnu? Tanish? Clear? Pramiti? Rakshita? Clear? Aditya? Going ahead. Next thing. Conservative forces. So what are conservative forces? If the work done by a force is independent of the path. And depends only on the initial and the final position. Yeah. So again, like state functions. So if you take work done in a closed loop, we get 0. So what are the examples of conservative force? So these are some of the examples. If something falls in this category, you can say they are conservative forces. A constant force. Constant forces are conservative. What's a constant force? Same direction, same magnitude. Central forces are conservative. Gravitational force, spring force, electrostatic force. And forces which can be described as perfect differentials. Do you remember perfect differential? We did last time. You should be able to write that in one single form. That was the last question, I guess. These were perfect differentials. So if the force can be written as a perfect differential, that is also a conservative force. Yeah, generally this is the idea there. You'll be able to figure out most of the questions you'll get with this thing. Either it should be constant force or gravitational or spring force or electrostatic force or central force or perfect differentials. If anything belongs to these four, it is a conservative force. But sometimes it is difficult to figure out whether it is conservative or not. For that, I'll show you how you can figure out mathematical method. But have a look at this page. Clear, everyone? Now I'll give you some forces. You tell me which are conservative and which are not conservative. Let's say f is 3i minus 4j. There, 8 of them. Now you tell me which one is conservative, which one is non-conservative. Look at the first one. This is a constant force, so conservative. This is also conservative. Why? You can write this thing as F is equal to R bar. This is a central force. This is also a thing. This is a perfect differential. If you see, I can write this thing as d of x square y square. Here t is time, huh? Now I'll tell you something about DC. Time varying forces are always non-conservative. This force is depending on time. That means if you go from A to B in different times, you get different works, isn't it? At a particular time, if you go from A to B, you'll get some work. If you go in different time, you'll get some other work. That means work done is depending on the path, right? And time here. So time varying forces are always non-conservative. So this is non-conservative. What about E? Try remaining. I'll give you one more minute. What about E? What is this thing? This is also central force. Now see, I can write this thing as r bar by r square. So where r bar is xi plus yj, it's a three-dimensional r bar. This is also central force. This thing is a tangential force. We discussed this. This cannot be written in the form of this cannot be written as a perfect differential. So generally you'll be able to figure out the answers like this. Have a look at this. Ask me anyone out of these eight anything that you're not convinced. Clear? Next one. Turn in the page. Now this is a mathematical technique. We call it partial differentiation. It's not tough, so listen carefully. Quite a useful one. We will encounter this at least another two more times. So the idea here is when you do partial differentiation, this is the symbol we use. We call it dou by dou x. It's not d, we call it dou. So the meaning of this is only x is a variable. I'll give you an example. That's the best way to see. So here, this symbol, it's called dou. So what this means is, example, listen, if I say dou by dou x of x y square z cube, the meaning of this is x is variable and you're keeping everyone else constant and y and z are constants. Now you tell me, while differentiating, what will happen to the constants? They will come outside. So this will be y square z cube dou x by dou x. Dou x by dou x is 1. So the answer is y square z cube. Let me take you one more example. The same one, if I say dou by dou y, x y square z cube, meaning here y is a variable, so which whatever you differentiate, only that is variable, you're taking everyone else as constant. So this thing is called as partial differentiation. Think about it. Normally, I should have used product rule, right? I'll get three terms. So this will be x into z cube dou by dou y of y square. And what is dou by dou y of y square? 2y. So this will be xz cube into 2y. So 2xy z cube. No. Same thing. If I take dou by dou z, now what will happen? X and y are constants and you will differentiate the z, which is xy square, and this will be 3z square dz. This is 3xy square z square. Check. Can you tell me what will be this guy then? Dou by dou x of xy square plus yz square. What is this? Hmm. So when I differentiate this, so this will be y square is constant. This will be dou x by dou x. This is y, z square is constant. This is dou 1 by dou x, means you're differentiating a number. So if this would be 0. So here this will be answer y square plus 0. Make sense? If y and z are constants, and if you differentiate a constant, you'll get a 0. Is this clear, everyone? This is partial differentiation. Now we have a test for, conservative force. Now sometimes what happens, right? Look at this one, the H1. When you see this sometimes, right, you're not sure whether it is conservative or not. I know you can't write as a perfect differential, but exam mein click nahi hota hai. So we have a method for this. Now this is out of portion. Normally you will learn this in engineering. It's a mathematical method, so it's not out of the world. So let's see this thing. In case exam sometimes it doesn't click, this will help you with the answer. So this is called curl of a vector. Now don't worry about what it is. This is given by something called del cross f bar. This thing is called del bar, which is a del operator. So which is dou by dou x I cap, partial differentiation with vectors. Again, don't worry, let me show you how it looks. Dou by dou z k cap. This is called a del operator. So when you do del cross f bar, we are doing a cross b cross product. I cap, j cap, k cap. Dou by dou x, dou by dou y, dou by dou z. So this is a fx is a x component of force, fy and fz. How to do this thing? If del cross f bar is 0, then we say force is conservative. Mostly you will not need this. You will be able to handle with what I taught you. Sometimes in case you couldn't figure out, it helps. Have a look at this. Let me show you an example. This is called a del operator. Clear? Let me show you an example. I'll show you one, then I'll ask you, you can tell me. So f is xy square I cap plus x square y j cap. I know this is a conservative force. It actually forms a perfect differential, but let's see. Let's say exam में click नहीं हुआ. This is a perfect differential. I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z. This is the fx component, which is xy square. This is x square y, and this is 0. Hope everyone remembers how to do cross product. Plus, minus, plus. So when you take the first column, take these two ka determinant. Then when you take the center one, take these two ka determinant. When you take the third one, you take this two ka determinant. Everyone remembers, right? A cross B cross product. But there are differentials here. So this is how it looks. So the first term will be I cap. So these two are gone. So this into this and this into this. Dou y of 0 minus dou by dou z of x square y. That is the meaning of that. Cross multiplication, you do partial differentiation. The second term is minus j cap. So you're taking this into 0, this into this. Dou by dou x 0 minus dou by dou z xy square. The third term k cap. Now we are taking these two. Dou by dou x square y dou by dou y xy square. Now if you can clearly see here, this is 0, so that you will get I cap. 0 ka differential is 0. X and y are constants for z, so that is 0. minus j cap 0. X and y are constant first at 0. This is k cap here. Y is constant, so this is 2xy. This is also 2xy. So this is 0. It's a conservative force. All three terms must be 0. I cap, j cap, k cap must be 0. Now, later on, when you learn little higher, you will realize, for example, let's say I cap is 0, but other two are not 0. You know the meaning of that? The meaning of that is when you travel only along x-axis, it's a conservative force. If I cap, j cap is 0 and k cap is not 0, it means when you travel in xy plane, it is a conservative force. So you can even classify further, but like I said, this is out of portion. Mathematically, this is a way to figure out if something is conservative or non-conservative. All three terms must be 0. Have a look at this. I'll give you one more. Now you try. But any doubts on this? How did I do this? Any step? How did I do A cross B? Please ask. Clear? Anyone, any confusion here? Great. Let's see. You try the same one. Let's say f is x, y, I cap, y, z, j cap, meaning देख के लग रहा है मतलब this can't be a perfect differential, but let's prove it. Is this conservative? What did you get here? I cap, j cap, k cap. Everyone should try. See? This is x, y, y, z, and x, z. I cap. So these two, dou by dou y xz minus dou by dou z yz. So here, if you see, this guy is 0 because x and z are constant for y. This is 0. This is 0. That will be I cap. When you differentiate with this, you'll end up with minus y. This guy is z minus j cap. This is k cap minus x. So there. This is not a conservative force. Check. Is this clear, everyone? Clear? Next one. Any doubts on this? Anyone didn't get any particular part here? Please ask. So this is one way to figure out if something is conservative or not. Next one. So that is about force, right? We saw different types of work. We saw, central forces, conservative forces. And if you see in all these things, 13 questions, right, are taught you only one thing, integral f bar dot dr bar. This is what I keep saying. You can take out the textbook and you can read, you can take the notes and read the theory 100 times. You'll not be able to do a single question. You have to solve questions in order to learn more theory. Right? You learn only when you solve problems, you'll figure out, okay, in this question, this is what happens. What did I teach you in this concept? Tell me integral f bar dot dr bar. Nothing else I taught you. And with that one thing, we just kept on playing, and we kept on twisting different things. The next thing is potential energy. Now, when I say potential energy, I'm not telling you what. I mean, it could be gravitation, spring, electrostatic, anything. So in general, so work done by internal conservative forces is given by negative of change in potential energy Now look at the meaning of this. What does this negative sign indicate? Tell me one thing. If you do work, what will happen to your energy levels? If you do work, what will happen? It will decrease, right? So the minus sign is saying if the system does work, the energy, the internal energy of its system decreases. So negative sign indicates when system does work, its energy decreases. Yeah. So work done by internal conservative forces is negative of potential energy. So if you write it mathematically, dW is minus du. U is the symbol for potential energy. Work done is nothing but F bar dot dr bar is minus du. So F bar is minus du by dr. Now understand one thing. U is potential energy scalar. F is force vector. So how do you convert a scalar into vector? Minus dou u by dou x, we use partial differentiation. I cap minus dou u by dou y j cap minus dou u by dou z k cap. So this is a technique of converting a partial differentiation is useful to convert a scalar into a vector because scalar will not have any directions. You should note this down. It's a quite a useful one. We are going to use this a lot. This will come in another 2 more chapters. But in terms of problems, you will see this thing in at least 6 to 7 chapters. This relation you will see in 6 to 7 chapters. So this is how you convert a scalar into, U is a potential energy is a scalar, you're converting into a vector force. Let me show an example how this works. Clear, everyone? Let me show an example. Now, in the exam, they'll ask a question like this. They will say, potential energy U is x, y square, z cube, the same one which I took before. And the question would be like this. Find force at the coordinate 1, 1, 1. This is how they'll ask you. Now, how do you do this thing? So first thing, let's do partial differentiation. Dou u by dou x, y and z are constants. So you have to differentiate only x. So this is y squared z cube. Dou u by dou y, x and z are constant. This is dou y square by dou y. That is 2xyz cube. Dou u by dou z, x and y are constants. 3xy square z square. This is your partial differentiation. Now what is the force ka formula? Force is minus dou u by dou x I cap minus dou u by dou y j cap minus dou u by dou z k cap. Substitute here. So minus y square z cube I cap minus 2xy z cube j cap minus 3xy square z square k cap. This is your force. So this is the force at any xyz coordinate. See how you converted a scalar u into like vector. Now you're asking at 1, 1, 1. So at 1, 1, 1, just substitute the values. Force will be minus I cap, minus 2 j cap, and minus 3 k cap. That's your answer. Please have a look at the steps. Ask me anything that you didn't understand, the partial differentiation, the formula, the substitution, anything you're not clear. Devika, clear with this? Which part you didn't understand, Samitra?
I did not understand the left part of the board where you wrote the part.
The whole thing, you didn't understand the whole thing.
Yes, so just can you once explain it? And
What were you doing till now, God? What problem? Doubt ka problem nahi hai. I explained it here, you didn't ask. I explained it here, you didn't ask. We did this problem. How did you do this problem then, 13, Samitra?
in this problem, I just used the form doing cross product. I managed to do it. Like I solved it quick.
Don't do such things, Samitra. Why bol raha hu? When you have a problem, raise it immediately. That means for last 2, 3 problems you're not understanding. You didn't bother to ask. At least good thing you asked now. Everyone, I keep asking you, have a doubt, ask. If you feel something is weird, ask immediately. Don't wait. Right? Because after this, I'll do 2 more problems. Whole thing will go over your head, and then you will think, "Arey, mujhe samajh mein nahi aaya." Should have asked it. We did 2 problems before this. My concern is that means how did you do this problem? Somehow you worked it out. what did I say about partial differentiation? If you have a quantity, let's say x square y, and when you differentiate this with x, understand the meaning of it. Only x is a variable, remaining all are constants. Matlab y is a constant. If you differentiate a constant, what will happen? It will come out, right? That you know, na? dy dx of 2x kya tha? 2 comes out.
Yes, sir.
So y comes out, and then what is left inside? X square. What is x square ka differential?
2x.
2x. बस यही था. So look at this thing now. So when I differentiated x y square z cube, right, with respect to z, what is a variable? Who are constants? Other than z, everyone else is constant.
Yes.
So x and y will come out then.
Yes.
So you have only dou z cube by this thing. What is z cube ka differential? 3z square.
Okay, sir.
No, you still didn't understand. What is this? Tell me. If I say dou by dou of x square y cube z power 4, इसका क्या होगा बताओ?
Sir, this will be x square into z to the power 4 and 3y square.
Then 3y square. समझ में आया ना?
Yes, sir.
Yep, you got it. बस इतना ही करना था partial differentiation. Everyone else, any other doubts? Please ask. Every problem I keep saying, any doubts? Please ask. Please ask. Ask. आपको लगता है ना? I understood, but ये थोड़ा weird लग रहा है. Ask. Don't wait. Problem is that asking doubts is not a problem. If you don't ask immediately within 1-2 problems, then the doubt will keep piling up. And फिर भी, now Soumitra, like, he took courage and asked, but some people keep hesitating till the end. Chapter gets over, they still don't know what is partial differentiation. Don't do such things. Ask, get it cleared. Got this? Let's see a question like this. Let's say potential energy U is given by sine of x plus y. Mass of the body is 2 kg. Find the acceleration of the particle at 0, pi by 4. How will you differentiate this thing now? Like I said, this is how you convert a potential energy, which is a scalar, into a vector. This is important. They do ask questions in mains level. This would be a proper mains level question. Meaning, if you have done work per energy in your classes, they must have taught you partial differentiation. So in case they didn't, there now you know. So it's not difficult. You just need to know whichever variable you're differentiating. सिर्फ वो होगा, बाकी सब constants है. Try this. I'll give you 2 minutes. Anyone still not clear with anything particular? Please ask. Get things cleared. Don't hesitate. Any answers? How do you differentiate sine of x plus y? Again, remember, this is partial differentiation. So dou y dou x of sine x plus y. Do you guys remember chain rule? This is sine of a function. But remember here, x is a variable, y is a constant. So it is as good as saying sine x plus some number. What is chain rule? Sine of a function is cos of the function. Then differentiate whatever is inside. Dou x by dou x is 1, and dou y by this will be 1 plus 0. When I differentiate dou by dou of sine x plus y, now this is constant, this is variable. Root 2, 0, it can't be 0, right? It can be root 2 though. This is again cos of a function. Now you're differentiating with respect to y, that means x is constant. So this will be cos of function. I hope everyone knows chain rule. In case you forgot, please go back to calculus and revise one. So this would be 0 plus 1. Check. So what is the force now? Minus dou u by dou x I cap minus dou u by dou y j cap. So this is minus cos of x plus y. Take out that common, you end up with I plus j cap. This is your force. Now at 0, 4, the force will be substitute there, that is cos 0, cos 45. I plus j cap. So this is minus 1 by root 2 I plus j cap. This is equal to mass into acceleration. And then you're done. So acceleration is 2. So my mass is 2, 1 by 2 root 2 I plus j. So if I ask you acceleration vector, this is the answer. If I want magnitude, then it will be half. Please check. Anyone confused with the differentiation, please ask. It's a chain rule. You're differentiating sine of a function inside. So sine ka differential is cos of a function, and then x plus y ka differential, but it is a partial differentiation. So y will be 0 here, x will be 0 here. Please check everyone. Anyone not convinced with this? Samitra, clear no? Now? Sure, right? Pranjali, clear with this? Devika? Rakshita? Kaushambi? Clear with this? Brijesh? Vishnu? Tanish? Anyone not clear with this? Midul? Navya? Clear? Kritik? Aditya? Devansh? Shaish? Clear? Let's see one more like this. Turn in the page. Soham, got this? U is x plus 2y. U is your potential energy. Mass is 1 kg. Initial velocity is 3I minus 2j. Find the velocity after 3 seconds. Meaning for a particle, this is the potential energy. So from potential energy, you have to find force. From force, you have to find acceleration. From acceleration, you have to find velocity. Let's get this. Right, Saish. What is force? Minus dou u by dou x minus dou u by dou y j cap. You can clearly see when you differentiate with x, y ka term will be 0. So this will be minus I cap. When you differentiate by x ka term will be 0 minus 2 j cap. Hope everyone got this. This is nothing but mass into acceleration. M is 1. So acceleration is minus I minus 2j. What is velocity? A is constant. Therefore, I can use the formula V bar is U bar plus A bar into T. You can directly use a kinematics equation. So V bar, U bar is 3I minus 2j. Acceleration is minus I minus 2j and time is 3. Multiply 3 I cap will cancel. You'll get minus 8j. That's your answer. There is no need to find I cap, j cap separately. You can just mix up the whole thing and finish with one vector form. There, differentiating work per energy. F is equal to ma loss of motion. Kinematics. 3 different chapters. This is how our mains question will be framed. Pushkal, clear with this? Anyone not convinced with this, please ask. Archana, got this? Okay. Next one. This is about, converting potential energy into force. Next time, equilibrium. Do you guys remember what is equilibrium? We have done already 2 times, one in vectors and one in NLMA. Equilibrium is simply when the net force on a system is 0, we say system is in equilibrium. If the net force on a body is 0, it is said to be in equilibrium. Now, in equilibrium, right, there are 3 types of equilibrium. So till now, we never bothered about this. We only found equilibriums, but you can classify them into 3 types. These are quite important. The first one is called a stable equilibrium. So tomorrow, if you're a mechanical engineer and you're designing some kind of suspension or some vehicle, you need to understand system can be in equilibrium, but what kind of system are you designing? What do you mean by stable equilibrium? I think I'll give an example that will be much faster to understand. Suppose if you have a valley like this, and inside if you drop a ball, now at this bottommost point, it will be at rest. If you keep it, it will be at rest. But if I disturb this, what happens? If I disturb here, it will try to come back. If I disturb to the left, it will try to come back here. So this point is called stable equilibrium. So when a body is in stable equilibrium, if you try to disturb it, it will always try to come back. Such a point is called stable equilibrium. If you keep it there, it will be at rest. But if you disturb, it will come back. If a body is displaced, from stable equilibrium, it comes back. So how do you find this thing? We have 2 conditions. Condition 1, force is 0, obviously. Condition 2, potential energy is minimum. This you studied also. Every system tries to achieve a state of least energy. So this is nothing but du by dx is 0. First differential is 0. Now you tell me if something is minimum, second differential kya hoga? Greater than 0, na? Hope you remember calculus में maxima minima everyone. This is condition for minima. Tanish, do you know this thing? What is the condition for maxima, Tanish?
Du by dx has to be equal to 0 and d square u by dx square has to be less than 0.
Yeah. So this is the second differential there. This is a condition for minima. Have a look at this. Yeah. Next thing, unstable equilibrium. Again, the best would be to look at an example. Imagine you take a hill like this. So this point now, imagine if I keep a ball here, right? If you displace it, see, can you keep it at rest? By carefully placing it, you can keep it at rest. But all you need is a small push, it goes away. These are unstable equilibriums. You can keep it at rest, but they won't remain in equilibrium. All you need is a little disturbance. Displaced, it goes away. Meaning, if you think about it, it kind of looks like this. For example, look at this. Now I have this book here. I can carefully place it like this. See, all I need is a small disturbance and it falls off. This is an unstable equilibrium. The little disturbance and goes off. But the same book, if I keep it like this flat on the ground, now see, if I try to disturb this, it always comes back, isn't it? So the same book, when it is horizontal, this is stable equilibrium. This is unstable equilibrium. Making sense? Getting it? So again, what is the condition for this? Condition one, force has to be zero. So in both stable and unstable, force is zero. What differentiates is the potential energy. Here, the potential energy is maximum. Du by dx is 0. And the second differential is less than 0. These things we have done in maxima minima. This is condition for maxima. There is a third type also. Called neutral equilibrium. Now this is when it is a flat surface. So if you have a body here, if you just push it to the side, it stays there. It neither comes back nor goes away. If you just take it from that position, keep it to the side, it will not come back, it will not go away. It stays there. This is called neutral equilibrium. So this condition 1 is of 0. Condition 2, du by dx is 0. The second differential is also 0. There, these are the three types of equilibriums. Yeah. Now, let me ask you something. Can you have both stable and unstable at the same point? No, don't get confused. Whatever I showed you now is in one dimensional. And you have seen this, you have seen stable and unstable both at the same point. You must have eaten it also. You must have eaten stable and unstable equilibrium. What do you mean by that? A Pringle. If you see Pringles, these actually have both stable and unstable at the same position. It's a two-dimensional. Look at this here. If you see, this is a valley, right? That's a stable equilibrium, meaning if you put a body there and displace it this way, it is stable. If you displace this way, this is unstable. So at the same position, you can have both stable and unstable. So Pringles have this thing. These shapes are called hyperbolic paraboloids. Parabolic hyperboloids. These shapes are pretty interesting shapes. These things, these hyperbolic paraboloids, right, have some very mechanical structural properties. One, they're very difficult to break. They're pretty strong. Meaning for the same type of size, if you make a chip which is flat and compared to this, these are pretty strong. Second, when they break, the whole chip will break at the same time. That is one of the property. Meaning if you make a perfect hyperbolic paraboloid, if it breaks, the whole chip will break at the same time. You can't break small pieces. Generally, Pringles are not exactly hyperbolic paraboloid, but generally. Means if you apply uniform pressure, whole thing will break at the same time. So when these people, right, the Pringles company wanted to make a chip, you have to make a potato thing, but they wanted it to be unique. So when they started working on it, they came up with this design. Think about it. First thing, look at the shape. It fits exactly on your tongue, isn't it? It fits over your tongue. If you can keep it exactly horizontal, it fits over your tongue. One. Second thing, ever seen a Pringles box? You can put Pringle on top of another like this. You can keep 30, 40, but the lower Pringle doesn't break. You will rarely find powder in a Pringles ka box. Lays ka packet karido, आधा powder मिलेगा. That is the second. Pringles can balance a lot. Third, when you put it in the mouth and apply pressure, when the whole thing breaks at the same time, right, your tongue will get coated with this, Pringles ka flavor 15 to 20% more. That means your taste buds will get activated. Meaning, think about when you eat normally. When you eat a chip, most of the time only your front part of the tongue is getting coated with the chip ka layer, that masala or whatever it is. But when you eat this and when the whole tongue is getting coated, right, your 15 to 20% of your sensory buds will get activated more. So you think the taste is more for the same amount of quantity. The chip actually tastes better. There. So that is how much work goes into designing a chip, potato chip. Right? And people think like, yeah, itna science क्यों करना है? And not only this, if you ever observed, this football stadiums ever observed? Football stadiums को ऊपर का cover ऐसा ही होता है. Ever noticed that? If you see these football stadiums normally, these stadiums and all, the top part of this covering, they looks in something like this shape only. Like I said, these are pretty stable shapes. कुछ याद आ रहा है? Something like this. Observe next time any football match or anything you're seeing, the football stadiums को ऊपर का cover देखो, it will be like this. Clear with this? So this is a hyperbolic paraboloid. Let's see how they'll frame questions on this. Let's see a question. So this is an FX graph. This is a UX graph. This is A, this is B, this is C. This is A, this is B, this is C. Which points are stable and which points are unstable? Be careful, one is an fx graph and one is a ux graph. That first one, 15A, was a previous year question. Surface should have friction, otherwise it will become unstable. No, Saisha, what I'm saying, Nasi, you're not pushing it. The ball is here, lift it and keep it here. Lift it and keep it here, don't push it. Matlab, just take it and keep it there. You're getting how it is. It's like this, I'm saying. It is there, here, take it, keep it here. Will it come back? It won't come back, it won't go. But unstable में क्या होगा? If I take from here and put it here, क्या होगा? चला जाएगा. I know, when I say push it, you thought I must be giving a lot of velocity. No, just gently, just a tap. How would you find out A, B, C, who is stable and who is unstable? Okay, let's see. First thing. First of all, for equilibrium, force must be 0. Force at B is not 0. So B is nothing. So B का discussion ही नहीं है. Force at A and force at C is 0. So between A and C are in equilibrium, B is not in equilibrium. So there's nothing to discuss about B. First of all, you have to be in equilibrium to be stable or unstable. Okay. Then first let's look at one of them. Now, if you want something to be stable equilibrium, we know the second differential dou square u by dou x square is greater than 0. This is for minima. And I also know f is equal to minus du by dx. So I can write this thing as d by dx of du by dx is greater than 0. This is d by dx of minus f is greater than 0. That means df by dx is less than 0. Meaning in an fx graph, slope is negative. So in fx graph, wherever slope is negative and f is 0, it's an unstable equilibrium. So if we look at here at point A, slope is positive, acute angle. At point C, if you see slope is negative. So this is a mathematical way of doing. So C is stable. Are you getting what we did? So the double differential can be written as two parts. D by dx of du by dx. Substitute f there. Be careful, f is minus du by dx. So that minus sign will mess up the sign again. Same way, if you take unstable equilibrium, d square u by dx square must be less than 0. This can be written as again d by dx of minus f. That means df by dx multiply minus on both becomes greater than. So slope must be positive. So wherever slope is positive, that is unstable. So A is unstable. Check. Any doubts on this? Now, sometimes mathematically इतना click नहीं होता है. How do you do this thing? There's an alternate way to figure it out. But have a look at this. Maximate is pretty straightforward. Clear with this, everyone? Kaushan bhi? Saish, clear with this? Arush? Om? Look at the alternate method. Alternate method is more intuitive. So fx graph. Look at this point A and point C here. So listen carefully what I do. Let's say if a particle is at A and if I push it little forward. Now if I push it little forward at this position, what is the force? Is it positive or negative? F is positive, right? Look at the graph. This is a graph, everyone. So if you push it forward, F is positive. Displacement is also positive. Meaning you tell me, if you go forward and the force is also forward, will you ever come back? You won't come back. Same way, if I push you backward, look at the force here. Force is negative, displacement is also negative. Will you come back? Isn't that unstable equilibrium then? If you put a particle at a position and if you push it, it is not coming back, it is going away. So it's an unstable equilibrium. So if a particle at A is pushed forward, right, force is also forward. It doesn't come back. This is unstable. Look at C point here. If I push it forward, force is backward. Force is negative, but displacement is positive. If I push backward, displacement is negative, but look at the graph here, F is positive. So particle at C comes back. So this is stable equilibrium. There, this is more intuitive way of figuring it out. Is this making sense, everyone? Agar wo mathematically, if it doesn't click, this is the idea. Put the particle at the equilibrium, push it little forward. If you say forward means displacement is positive. If force should be negative to come back. If force is also positive, displacement is also positive, you will keep going forward only. Is this making sense, everyone? Sure, everyone? Question still not over. What about the second guy then? If it is a UX graph, who is stable and who is unstable now? Try, I'll give you a minute. Instead of FX graph, if UX graph is given, then how will you find out? Right, Arush. Let's see. Actually, the UX graph is the most easiest one to figure out generally. This is A, this is C, this is B. So first of all, force has to be 0. Force is nothing but minus du by dx. That is du by dx is 0. Slope must be 0. The only slope at B is 0. So B is in equilibrium. Slope at A and C are not 0. They're not in equilibrium, so there's no discussion there. And you can clearly see here, B has more potential energy. At B, potential energy is maximum. बस हो गया वही करना था. Unstable equilibrium. Slope is 0, so force is 0. It's the maximum point. Clear? So if I give you UX graph, that is the easiest to find. In an UX graph, if I give like this is stable, this is unstable. The headache is FX graph. FX graph is where it requires more effort, but UX is easy. Check it out. Isn't that the definition of unstable equilibrium? Potential energy is maximum. In a UX graph, the B point has a maximum potential energy. Please check. Yeah. So that is the relation between forces, potential energy, and equilibrium. So this is the third time you encountered an equilibrium. Next one. Now let's see the different types of energy that we will deal with. The first one is gravitational potential energy. We'll also call this thing as GPE. So if you take a body M here and you take it in some random path to here, let's say you're going from point A to point B. Let this height be HA, let this height be HB. Now we can clearly see no matter how the body goes, the gravity is always acting downward. Therefore, work done by gravity is the force minus mg j cap, and displacement is hb minus ha j cap. The vertical displacement. It is minus mg hb minus ha. This is the work done by gravity. When you go from A to B, it depends only on the height. But we already know from the definition, work done by internal conservative forces is minus delta U. So minus hb minus ha is minus delta U. So the difference in potential energy is mg minus ha. There, so we can write like this. So delta U is mg delta h. So change in potential energy is mg into change in height. So gravitational potential energy depends only on the height. It doesn't matter how much you travel horizontally. I'm sure you studied this in school, right? Potential energy. Now here, suppose if you take A as a reference, then we can take the height of A is 0. Then we get U is equal to mgh. Be careful, h is the height from reference line. What do you mean by that? Let me show you an example. Now, let me ask you a question. So let's say if I have an incline like this is height h, this is the block M. What is the potential energy of this block? What is the potential energy of this block? First thing you should ask is, sir, what is your reference? It's not mgh. So if I take this as my reference 1, I can take this as my reference 2. I can take this as my reference 3. Let's say this is also height h. Now see what happens. If you look at the potential energy of the block, suppose the same potential energy when it is the block is on ground, and if you calculate the change in potential energy, three different things I'm trying to calculate. Reference 1, reference 2, reference 3. Now you tell me, if I ask reference 1, what is potential energy of the block, what will it say? mgh. If the same block is on the ground, then what will it say? 0. What is the difference? mgh. If you ask reference 2, what will it say? 0. What is this? Minus mgh. But what is the difference? 0 minus of minus mgh. It is still mgh. If you ask reference 3, minus mgh. When it is on the ground, minus 2 mgh. What is the difference? mgh. Did you notice something? Potential energy will depend on the reference line, but the difference in potential energy won't matter. I'll give you a crude example. Let's say you have a scale and it is broken. Can you tell me what division is this? Chalo, suppose if I say this is 4, now can you tell me what is this? How much? 5. Suppose if this is 9, how much is this? 10. If this is 17, 18. But without seeing anything, can you tell me what is the distance between these two? 1, right? It doesn't matter what is the division of this, the difference between them is 1 centimeter. If it's a centimeter scale. Are you getting my point? So potential energy is like that. Potential energy depends on reference. Potential energy depends on the reference. Depending on where you're seeing, I can get potential energy positive, negative, 0, any value I can get. But potential energy difference, that is independent of reference. Meaning if I ask you, the block goes from here to here, what is the change in potential energy? I need not ask you what is the reference. This will be a theoretical question, everyone. Change in potential energy is independent of reference. Have a look at this. Have a look at this page. Ask me if you're confused. Next one. Next one. Spring potential energy. We'll call this thing SPE. If this is K and this is your natural length, and let's say if this is your elongation, this is your force, we know the spring force F is minus Kx bar. The work done by the spring is, because both are opposite, minus Kx dx, 0 to x. So this would be minus half Kx square. Again, same story. We know work done by internal conservative forces is negative of potential energy minus half Kx square is minus delta U. There, so the spring energy is given by half Kx square, where x is either elongation or compression from natural length. So whenever you stretch a spring or compress a spring by x, this much energy you need to give. So here your reference line is always the natural length. There, this is your second potential energy, spring. So gravitation is mgh, spring potential energy is half Kx square. K is the spring constant. Any doubts on this? Next one. The next one is your kinetic energy. So in mechanics, right, generally until we start electrostatics, these are the three energies we will deal with: potential, gravitational potential energy, spring energy, and kinetic energy. So our entire mechanics is based on these three. So let's say we have a block of mass m going with speed u. Let's say we have a person A here who is at rest. And let's say we have a person B here who is going with V. Now, if you ask A, what is the kinetic energy? He will say half mu square. But if you ask B, what is kinetic energy? He will say half mu minus V whole square. So kinetic energy depends on frame of reference. Just like work done depends on who is observing you, kinetic energy depends on frame of reference. Again, a good theoretical statement that is. You see, two people seeing the same block will say they have different kinetic energies. So kinetic energy is half mu square, multiply and divide by mass. We get mu whole square by 2m, which is p square by 2m. P is momentum. This is also quite a useful one. We use this a lot. So momentum is given by root over 2 times mass into kinetic energy. You know, where did we use this before? In errors. If the error in momentum is 50%, find the error in kinetic energy. Do you remember? We did a question like that. 1%, 10%, 100% wala question. That way. There. So these are the three energies that we will deal with: gravitational potential energy, kinetic energy, and spring energy. Check it out. Why people are so tired? You guys all are waiting. Yeah, class gets over, we'll go and play Garba, something like that. No. There. So that's the last one for the day. So do make sure to go through the notes. We did a lot of theory today, right? And we did some good problems also. There were a lot of new things: central force, conservative force, partial differentiation, stable, unstable equilibrium, types of energy. Still find these things, we have a little bit of an idea. So next class, when we catch up, the actual game starts. Like we will be starting with, work power energy. So that is the, conservation of energy ka theorem we will do. And then we'll start off with the problems. So till now, all your basics are done. Now we will be starting off the actual ones. You'll have more varieties, you'll get everything. And okay. So next class, when we catch up, we'll finish off with this. So do start solving, your kind of circular motion, whatever is pending, do finish it off. Now we will see, any doubts in your